So last class, we got on our graphing calculator and we looked to see where the x-intercepts were. And we found an x-intercept at -1/2. And we found another x-intercept at 3/5, positive 3/5. And I told you if it's a power, you're down to a quadratic. So finding two x-intercepts using your calculator is totally fine. But now we have to use the stuff that we've learned in class to finish it. So what we're going to do is we're going to take out the factor of 2x plus 1. By the way, just from review from last class, these factors will not have fractions in them. So when you set x equals -1/2 and you have to make it say equals 0, you first multiply by the denominator to move that 2 up. And then we add the 1 to get 2x plus 1 equals 0, then it's a factor. So just remember, if it's a fraction, it has to not be a fraction in this factor. Okay? So now what we're going to do is we're going to take out 2x plus 1 and take out 5x minus 3 from this. All right, there's a couple ways you could do this, but there's a way that you can't. What was the method we've been using to take this stuff out? What was the way that you did on your assignment? How have we been taking stuff out? I can't use for this one. Why can't I use synthetic division? Because there's a number other than a 1 here. Same thing. There's a number other than 1 here, so we can't use synthetic division. What are we going to have to use instead? Long division. So we can either do long division twice, or we can multiply these two together and do long division once. Your preference. Would you like to do long division twice, or would you like to multiply these together and do long division once? Okay, let's do it that way. So if I'm going to multiply these together, you're more than welcome to use your like box method if you like that, or you can use FOIL method, whatever method you prefer. I like FOIL, but I know a lot of you like this one, so I'm doing it this way. I only like FOIL because I was raised on FOIL. So I get 10x squared minus x minus 3. So I'm going to divide that out of 10x to the 4th minus 11x cubed minus 42x squared plus 7x plus 12. We're going to use long division. So we review long division. How many times does 10x squared go into 10x to the 4th? Okay. No, not once. No, not twice. Okay, so if you're not sure of the answer, remember we can do 10x to the 4th divided by 10x to the 2nd and simplify that. And when we use division, what's left over? X squared. That's how many times it goes in. It goes in x squared times. Then we distribute. Divide, multiply, right? 10x to the 4th minus x to the 3rd minus 3x squared. And we subtract. And when I subtract, as soon as I draw a line, I change all the signs and add them. These cancel out. We get negative 10x minus 39x squared plus 7x. Bring it all down and bring it all back. Long division. What do we do next? 10x squared, go into negative 10x cubed. If you don't know, then you go negative 10x cubed divided by 10x squared. How many times is that? Negative x. So when we go to distribute, we're distributing a negative x. So we get negative 10x cubed plus x squared plus x. I draw my line. I change all the signs. and then I add them. Cancel, we get negative 40x squared plus 4x. Bring it on down. Bless you. Bless you. All right, now we go 10x squared into negative 40. It's going to be negative 4. And we distribute. I get negative 40x squared, positive 4x, positive 12. What happens when I subtract these? Now, that should happen because we already determined that these were factors. If it doesn't happen, maybe you like multiplied wrong. But it should work that way. And what do we have left? What kind of power degree type equation do we have left? We have a quadratic. So now we have to use other things that we've learned in class to find the solutions for x squared minus x minus 4. What are my for solving x minus x minus 4? Factoring. Does it factor? Did you try? Well, not everybody has that. Oh, yeah. 4 and 3 or 4 and 1 is going to make 3 or 5. 2 and 2 is going to make 0 or 4. There's nothing that's going to make 1. So it's not factorable. What other choices do I have? It's an entire chapter that we did. Besides factoring, what do you say? GCF is factoring. It's not factorable. You could either do quadratic formula, or what's the other one? Complete the square. Now let me think. If I like complete the square and I go to do it, what's going to happen in the middle? Have we forgotten all of our other methods? Because all math comes back, and you can't just learn something for a test and purge it using all the same stuff we used before. If I'm doing complete the square, remember you have to do like b divided by 2 squared? Well, b is negative 1, but what happens when I divide it by 2? And then I have to square it. Do you want to do fractions? So then maybe we do quadratic formula. Okay, so x equals opposite b plus or minus square root b squared minus 4ac over 2a, and a is 1, so just 2. Simplify. X equals 1 plus or minus square root. That's going to become 17 all over 2. Yes, yes.
Isn't like the one supposed to be negative?
Which one?
The
This one? This one?
that one and the other one.
This one?
No. That one and the one that's B4.
Oh, this?
Yeah.
Well, this is A. This is 4AB, or 4AC, so no, that's a positive. This one is B squared. So if I take a negative 1 and I square it, what's negative 1 times negative 1, Martin? Positive 1. So that number is also positive. Okay? So you guys, can I simplify this any further? So these are the other 2 zeros. These are the other 2 zeros. So for this to be factored all the way, I'm going to change my color so you can see. I'm trying to figure out where I wrote so big with those other stuff. I guess I'll, can I write it sideways? Can I write it this way so I can fit it in there? Does that bother anybody? Sorry, I wrote way too big with the other stuff. So for this to be factored, we have those 2 factors that we got from looking at the calculator. 2x plus 1 and 5x minus 3. And now our other two factors, we have two more factors. I still didn't leave myself enough room. One's going to be x plus 1 plus square root 17 over 2. And the other one's going to be x minus, nope, plus, oh, wait. Just kidding. They're going to be minuses. Sorry, both are going to be minuses. 1 minus radical 17 over 2. I can talk about why they're both minuses. I kind of talked about it last time, but I didn't. So that would be the factored form of this guy. So when we're on our calculator, if you actually tried to find these two x-intercept, you would get a horrible that you would not be able to do anything else with. So if you're getting a horrible decimal that you can't do anything with, like if you get 0.3 repeating, you should know that's 1/3. But if you get just like 0.69427, then that probably means you're going to have a radical for that answer. How I knew that they were subtraction, because remember, in order to write this as a factor, we have to make it say equals 0. And how do I get this entire chunk over? Oh, you don't have to do that for this one. Yeah, subtract it to get over. Yeah, you just subtract this whole thing. Katie, you need to do multiply by 2, and when you don't think we have enough time in the semester to truly grasp that. If you'd like to see me, I can talk to you and tell you to move it over. But if it's whole numbers, like not disgusting looking, then we are definitely going to do that. Well, what's it asking? Find all the zeros. So I wrote the factored form. The zeros would be like x equals negative 1/2, positive 3/5, and then 1 plus or minus square root 17 over 2. That would be the, did I record? Oh, I am. Okay. That would be the zeros. Okay. All right, so we're going to try maybe 2 more of these, and then there's one more thing, actually in both packets that we have to learn. And it's easy, but it starts in 4-5 day 2, and then it's also, so we get the same thing kind of twice. That's why I said I can kind of combine this stuff and not do. You guys know when you have a quadratic, like we just had x squared minus x minus 4, and we solved it, and we on plus or minus square root of 17 over, what was it, over 2, okay? If I have a radical answers, one of my x-intercepts, it will never be by itself. It always have 1 plus and 1 minus. If I told you one of the x answers was radical 3, you could say one is x equals negative. Always come in pairs. Are always in pairs together. You won't have one square root without a second square root. Always in pairs. Okay? So when I go to this next question says, write a polynomial function f of least degree that has rational coefficients, which means not square root coefficients. A leading coefficient of 1 starts with 1. So that means there's no stretch or shrink. And these zeros, 0 of 3 and a 0 of 2 plus radical 5. That means x equals 3 is a 0. That means x equals 2 plus radical 5 is another 0. But according to this theorem that I just went over, you can't have one square root without its friend. So because I see I have a square root, we have to put in its friend. And it's going to be what's called the conjugate. What's called the conjugate is the friend. Conjugate. What would x equal to be the friend? Does anybody know? Chris, do you know? Bryce, you know?
X equals 2 minus.
Yeah. X equals 2 minus square root 5. Those are the conjugates. Those are 1 plus and 1 minus. That's what conjugates means. Okay? Now what we have to do is we have to find the original polynomial function that these are the answers for. We're going to turn these into factors. You guys already know how to turn them into factors. I've taught it. What do we turn into a factor? Why are we doing that? Because we're trying to make this what? Make this equal to 0, so we're going to subtract 3. We get x minus 3 equals. That means the factor is x minus 3. There's that factor. What do we do for this one? Needs to say equals 0. What should we do?
Subtract.
We're going to subtract 2, and we're going to subtract radical 5. So I'm going to have x minus 2 minus radical 5 equals 0. So my factor for this one is going to be x minus 2 minus radical 5. That's my factor. And then the third one, we're going to subtract 2, but then we're going to add radical 5. Of x plus 2, just kidding, minus 2 plus radical 5 equals 0. So our factor is x minus 2. So this is an f of x equation. Now it has to have rational coefficients, a leading coefficient of 1. It has to have these factors. We're going to multiply it out. You already know how to multiply polynomials. But I'm going to give you a huge, huge, huge hint of what will make your life much easier. Totally new, I think I would say as well. Multiply the two yucky ones first. Do these first, because you can't multiply them all at the same time. That answer by x minus 3 to make it much easier. So how can we multiply? We could do FOIL multiplication, or we could do the box method. Your choice. Okay, let's multiply. And some amazing, amazing stuff's going to happen. Terms by 3 terms. Made a little bit bigger for you. So I multiplied it out. You can multiply by whatever method you want. Then we have to collect. So as I'm collecting like terms, what is like terms with x radical 5? Negative x radical 5. And guess what happens if you add x radical 5 with negative x radical 5? Bye. What's like terms with 2 radical 5? Oh no, one of them should have a negative. My bad. Comes with negative 2 radical 5. Positive 2 radical 5, so they cancel each other out too. So we are left with x squared, and here minus 4x, and we find some like terms this direction, minus 1. So now all we have to do is multiply this answer by x minus 3. I'm not doing a very good job of placing my stuff on the paper to minimize, the space I use up. I'm doing a bad job about that right now. How do we multiply a binomial times a trinomial? FOIL, or the box method, or there's the vertical method as well. It's like really up to you which method you want to use. You do whatever method you want. I was just trying. I'm going to use the box method because when I'm looking at my space, that's all I have space for this one otherwise, but I just realized I did a terrible job at organizing my space. So we got x minus 3, x squared minus 4. So I have x cubed minus 3x squared plus 4x squared. So after doing the box method or FOIL method, whatever method you prefer, you should have x cubed minus 7x squared plus 11x plus 3. How about next time I organize my work? Did I make a mistake? Did I make a mistake? I tend to do those, especially when my work's not. Am I right?
What you got?
I got. Is that what you got?
Yeah.
So I'm not going to do this one all the way. I'll do a different one all the way. But if we are doing this one, if we have zeros at 4 and we have a 0 at 1 minus radical 5, we'll have. So we will have another 0. What's it going to be? Right, the conjugate is going to be x plus, 1 plus radical 5. And one more step, putting these into zeros. Factors. Remember, we have to make it equal to 0, so I'll have x minus 4 for that one. Equal to 0, then I'm going to subtract 1 and add radical 5. So my second factor will be x minus 1 plus radical 5. If we have to make it equal to 0, I'm going to subtract 1 and subtract radical 5, giving me x minus 1 minus radical 5. And then from there, you multiply it all back together. Huh?
That's more neat.
We will keep going on a different question.
Wait.
I don't have time to do every single example all the way. I have to get.
Yeah,
What are you confused on?
I understand that.
No, those of you that are saying you are confused, what are you confused on?
No, I was just saying like the way we did it just like that, and it
Uh-huh.
became more.
Okay. Okay. We're almost done. We just have to do some more examples. I've pretty much taught you everything you need to know. We just need to try a couple more examples. That's it. Okay? On this page, it has some corollaries to the fundamental theorem of algebra, but we're not going to worry about that. We're just going to worry about what it means. And I've actually taught you this the entire chapter, even though we never really had. But I've already taught you this the whole chapter. Looking at question A, how does it have? Question A. If I were going to find all the x-intercepts, how many could it have? Why are you saying 3, which is correct? Why are you saying 3? The degree equals the number of solutions. Right? So this solutions. Now, some of them could be repeated. Some of them could be imaginary, but it has 3 solutions. How many zeros does this function have? 4. How many zeros does number 1 have? Or solutions? 4. Using different words here. How many zeros does number 2 have? 3. So easy. We have done that before. So let's review this kind of question again. See, it says factor out zeros using synthetic division. We need to graph it on our calculator. So go ahead and pull out your graphing calculator. And go to y equals, and we're going to type in this equation. How many solutions are we looking for this one? Or how many zeros? We're looking for 5 zeros, okay? Now I've hit graph, and I don't see 5. Nope. There might be some repeated. There might be some imaginary that you can't see. Okay, so that's what's going to happen in this one. Actually, both things happen in this one. Okay, so last class we talked about the behavior at the x-intercept depends on the repetition of that x-intercept. So what do you think this x-intercept might be right here? Okay, let's check. Let's do second trace value, type in -1, and yes, that is a 0. That confirms it is a 0. So I'm good. That is a 0. However, what is the behavior at this 0? So what does that mean about how many there are? There should be a multiplicity of 2. So we're going to guess, and this is a guess right now, so we're going to guess that x equals -1, and I'm going to just write twice. And then, what's this other x-intercept, do you think? 2? Let's see. Second trace value, 2, enter. Yes, 2 is another one. So x equals 2. How many do I need? I need 5. How many am I allowed to use my calculator for? 3 of them, which is all I could use my calculator for. Okay? So what we're going to do, can I use synthetic division if it's a -1 or a 2? Synthetic division? Yes. It's just when it's like a fraction. That's the kind you can't use synthetic division for. So I'm going to use synthetic division, and we're going to take out -1. So I've got, oops, it's going to be 1. X to the third comes next. What does that tell me? 4. Then we've got a 1x to the third, -2x squared, -12x, and -8. My synthetic division at lightning speed. is not 0, either you found the wrong x-intercept or maybe you made a mistake in your work right here. These should all have remainders of 0 if we found that they are zeros. Question?
Why did we use -1 for like multiply? You know,
Why did we use -1 here instead of what?
like just why did
The x-intercept.
we not 2?
Well, we're going to use the 2 still.
Oh.
We haven't gotten that far yet. That's okay. What?
The division twice, like 1 with the 2.
We're going to do it 3 times, but I want to make sure that everybody's on before attention and lose it. You ready? You all have to hear. So, what I've done is I've factored out the first factor. I am not going to go back to the original anymore, because we want to factor out more and more and more and make what we have smaller and smaller and smaller until it gets down to a quadratic, which I can solve a different way. So what I'm going to do now is I'm going to take this stuff that's left over, and I'm going to put the new thing I'm factoring out just off of the answer here. So what's the new one that we're going to factor out?
Factor out -1 again.
We need to do -1 twice. Now, if you did a 2 first and then you went back and did a -1, your work will look different, but you'll still get the same thing at the end. Okay? Yeah.
When you do it the second time, did you just ignore the 0 at the end?
Yep, because that is the remainder from before, and that's not the new equation. Line. Oh, I think I normally do this. I can't remember. I like make a box, so I'm like, don't look at that. You know, distracted and look at it. So I have to like box it out. Uh-oh, nope, this didn't work. What did I do? 1. Oh, I don't know why I skipped that. I started talking, that was the problem. Okay, oops. So that one gave me a remainder of 0 as well. But we're not, because we still need to factor out the 2. So I drew kind of like around this so I don't look at the stuff from before. Bring down my 1, multiply. Of 0. So so far it's looking good. Now we need to write the quadratic that's left over. X squared plus 4. We're going to set it equal to 0 so we can solve that one. You may use whatever method you want to solve, but factoring is not going to work for this one. If factoring worked, it would have showed up on the graph. So your choices are, complete the square is not a choice.
Can you just subtract the 4?
Yeah, that's square roots. Totally. Like x squared equals -4, and then square root both sides, plus minus. We can have a negative, you just have to call it I, so I get plus minus 2I. So it says find any zeros, repeated solution. So what I'm going to do is I'm going to show you what the zeros would look like and what the factors would look like. It doesn't really say write it in factor form, but I'm just kind of combining some stuff. Okay? So the zeros, -1, 2, and plus minus 2I. Remember that -1 happens twice, but you don't have to write it twice. And plus minus 2I doesn't show up on the graph. What?
Once you multiply it by the -1 twice and the 2, then you're done. You just like put it in the brackets. Is that what you mean?
You lost me at once you multiply the -1 and the...
Like once you, I mean, I meant to say once you divide.
Oh, once you
Like,
divide out these,
Yeah.
well then you just solve whatever is left over.
And then that's your answer.
Yeah, well for zeros, if it asks for zeros.
Okay.
Now if it asks for factored form, we're going to write it all as factors, which if I have x equals -1, what will be my factor? X plus 1. So I'll have an x plus 1. What does twice mean? Squared, yes. Twice means there's those. And then we'll have our second factor, x equals 2, so x minus 2. The last one doesn't factor, but you can write it as factors. If you just take this here and you move the stuff over, like x equals 2i, and we move it to the other side, we get x minus 2i. Or if we have x equals -2i and you move it over to the other side, you get x plus 2i. So I have it factored all the way, and I even have imaginary factors in there. What? I think the majority of this is going to be finding the solutions, probably not as much of this. Because this, if you don't get it all the way, we hit this again in your next course. Oh, here's all my notes for solve the remaining. So there's a few, okay, I'll go back in a second. There's a few of student practice, but before I spend time on student practice, I just wanted to go over this one more time that we did on the other note. They're not page numbers, but you just skip another page. It's the back of the next page. This theorem is a theorem I already went over today. They call it something different, but I promise you I already went over this today. If we're given some zeros, like I'm given x equals 2, and I'm given another 0, x equals 3 plus I. What is I? It is not -1. It's the square root of -1. I squared is -1, yes. So when I say what is I, you tell me square root of -1. So if I have a square root here, and we're writing this out, and we're multiplying it all together, if I have a square root, I have a friend to go with it. I have a conjugate friend. Which is what we just did earlier a moment ago. Conjugate friend. So if I have 3 plus I also have x equals what? 3 minus I. There's 1 plus and 1 minus, because that is a square root, and that's the rules. They're negative. They're always pairs. So now we're going to go through this all the way, and we're going to set each of these equal to 0. So I have x minus 2 equals 0. I'll have x minus 3 minus I equals 0. X minus 3 plus I equals 0. That gives us the factors. X minus 2, x minus 3 minus I, and x minus 3 plus I. Oh, it's not equal 0. It does tell me it's f of x, so I'll read my directions and write f of x. Oh, it can if you're finding zeros, but we're not actually finding the zeros. They've already given them to us, so now we're just going to put it back together. This says write the function f, so it tells you to call the function f.
Oh.
Okay. All right, so now I told you this before. Which two would you suggest, according to my direction, which two should you do first? The gross ones. Do those first. You can do it by box method or you can do it by FOIL method. That's totally up to you. It's going to be a 3 by 3. So when I multiply those all out, in this last corner, I got negative I squared. And remember, what is I squared? Negative 1. So if I have negative, negative 1, what is this last box? That's going to be a plus 1. We combine our like terms. If you're paying close attention, you'll see that negative xi and xi cancel. And negative 3i and 3i cancel. Like all the i's when you do this. So we have left over sorry. I was just rewriting the beginning of this. We have left over x squared minus 6x, and then 9 plus 1 is 10. We have one more step. We just need to multiply these back together. And pending I didn't make any silly mistakes, that should be my final answer for that one. Hold on. I'm gonna get through. Ask somebody around you. Okay. Bye. Hang on. You're leaving. What now, Devin? Where'd I get what?
The lower box. The lower box.
I was these two things? Oh, I'm sorry. It's from here. Well, the x minus 2, I just brought it down. And then I multiplied that stuff together and got this. And then I multiplied those two together and got that. Okay. I think I'm going to put your stuff on big ideas. Wasn't quite sure how far we were going to get today. So I'm going to put the assignment on this.
Finishing the homework.
Oh, you guys? You guys? What? Guys, the 4-point worksheet that you couldn't ask for, just don't worry about those yet. Don't scribble them out. Maybe we'll do them tomorrow. But I will on for you to practice what we just went over. Okay?